Hi guys, how's it going? Been a long time. Sorry that we could not be together in person. These are crazy times. I hope you're all doing well. You're all safe, and I hope we can get back together at some time soon. Although I'm not sure if that's going to be the case. So we had our discussion online, but if you were not there, my approach is going to be that I'll have video lessons for you for each lesson. Some of them might be ed puzzles, some of them might just be YouTube, but there'll be stuff for you to do. And hopefully we'll be able to post online questions, and as much as you can, I'm hoping that you'll be able to answer each other's questions, and when needed, I can step in and help as well. So our first lesson is kind of a review of last unit, but it goes a bit deeper into what's called the unit circle. Before we do that, though, let's talk about those special triangles or the special angles. You may or may not remember, so there was two of them. There's the 45, 45, 90. So that's this guy where we've got 45 and 45. And then obviously the right angle is the 90, and these sides are 1, and then the hypotenuse is root 2. Then there's this one, which is the 30, 60, 90. And opposite the 30 is the shortest side, which is 1. And then opposite the 60, the next shortest side, which is root 3. And then the hypotenuse is 2. Okay, so we had filled in a table similar to this, except for we had not dealt with the 0 degrees, 90, 180, 270, and so on. But before we go, let's just remind ourselves the old SOHCAHTOA stuff here. If I've got sine of 30, so this one here we'll start with. So if I go to 30, opposite over hypotenuse for sine, so that becomes 1/2. And if you want, you can fill this in yourselves. Cos of 30 adjacent over hypotenuse becomes root 3 over 2. And then tan, which is opposite over adjacent, becomes 1 over root 3. And what we're going to do now is I'm going to change this actually into the rationalized numbers, so we get rid of the root in the denominator. So if I multiply both the top and the bottom by root 3, I get root 3 over 3. So we're going to use that number from here on in pretty much. The next one, if we go to 45, so go to the other triangle, opposite over hypotenuse becomes 1 over root 2. Let's rationalize that. So it becomes root 2 over 2. And that actually is the same as this one, root 2 over 2. And then tangent is just going to be 1 over 1, which is 1. And then 60, if we do this one quickly, I get root 3 over 2. I get 1/2. And then I get root 3 over 1, which is just root 3. So again, that's just review. So now in these other cases where we have 0 degrees and so on, what we can do is look at what's called the unit circle. So try to sketch in here on your page some sort of circle, and mine will be probably pretty bad. But let's imagine this is some sort of perfect circle with the radius of 1. So all along from the origin out is 1, like that. So if I was at 30 degrees, I would go somewhere like here. So this is my point, which is xy. You can draw this in. I drop that down. So I get a quarter of the bow tie, and this is 30 degrees. So that's pretty easy. Remember, always we've got sine of whatever angle we're talking about. It's equal to the opposite. In this case, opposite is y, adjacent is x, and our radius we'll call r. So it's y over r. But if r is just 1, or the radius is 1, then sine of theta is really just y over 1, or just y. And then cosine is adjacent. Adjacent in this case is going to be the x. So I get x over r, or x over 1. So cosine of theta is just x. And then tangent is opposite over adjacent, which becomes y over x. So if we start thinking of this idea of having 0 degrees, so 0 degrees, if I just change colors, would be down here, right on the x-axis. And so if you look at the value, if this is a radius of 1, this would be the point where x is 1, and I have no height, so y is 0. So you can use the sine equals y, cos equals x, and tan equals y over x in order to figure out each of those at 0 degrees. So if I do that, sine of 0, sine of y, in this case y is 0, so my answer here would be 0. So it's just the y value. Cosine is going to be 1, and then tan is going to be y over 1. So in this case, it would be 0 over 1, which you can do. 0 divided by 1 is still just 0. So our value is 0 there. So as we go around the circle, let's say I'm at 90 degrees. At 90 degrees, my x value now is 0 and my y value is 1. So we use the same idea for the next one. So sine equals y, so that's just going to be 1. And then cos is x, so that's going to be 0. This time for tangent, I end up with y over x, which is 1 over 0, which is an error. It doesn't exist. So there's a couple times when tangent doesn't exist for these values. Next one's 180, so let's move over here. Now I've got -1 for x and 0 for y. And so we start to get into the CAST rule, if you remember, which determines which trig ratios are positive and negative in each quadrant. So if I have 180, again, my y value is 0, so that's 0. But my cos is going to be -1, like that. And if I do the tan, I got 0 over -1, which is just 0. So see if you can figure out the next two. So if you want, you can pause this. Otherwise, try it yourselves. So this one's going to be 0 and -1. So this one's going to be y is -1, x is 0. And then what happens again here for tangent, if I have y divided by x, that's just going to be an error. So this is -1 divided by 0. Again, is an error. And then when we're all the way back to 360, should get the same as sine of 0 because we're at the value where x is 1 and y is 0. So we end up with the same things as the other column here. So I'll just highlight these two. So this column and this column should be the same because it's really the same angle. Like that. So you really just have to remember a couple things here. Let's make this bigger. Sine is this, cos is this, and tan is really x over, or y over x rather. Okay, and that's kind of all summed up here for you. What you can do is you can go through, and some people prefer to represent everything like this, which is really the full filled in version of the unit circle. I'm not a big fan of it, but you can definitely use this. So again, we've got x, so we fill in what the values would be at x. So if I was 0 degrees, and this is a unit circle with a radius of 1, this value, like we filled in before, is going to be 1 and 0. And so you can use that in order to find out sine and cosine, or even tangent. So if I was at 30 degrees, let's say that's the first one here, so that corresponds with this. My value of x at 30, like you dropped this down and you created your 90-degree triangle opposite to 30 using 9 special triangles would be 1. This would be √3 over 2. And this is going to be obviously r. Oops, r is not 1 in this case. It's going to be my hypotenuse, which is 2. So you would just fill in your x and your y. So I've got x is √3 over 2 and y is 1. So knowing that sine is y and x represents my cosine, you can figure out cosine of 30. Again, you don't need to use this method, but you can. Cosine of 30 is going to be the x value, which is √3 over 2. Sine of 30, which is going to be the y value, is just going to be, oh, I put 1. No, that's right. 1 over 2 for my y value, because I've got my hypotenuse, like that. Okay, through the magic of technology, there's the filled in version. If you want to copy that down, you can. You certainly won't be tested on filling this out, but it's one way to figure these values out. One thing that we're going to see later on that you should pay attention to is really, because tan is y over x and sine is y and cos is x, it works out that tan is equivalent of sine over cosine, and we are going to talk about that later on. But what you really want to be able to do is something that we did do last unit, which is using cast rule and the exact values in order to figure these things out. So it says determine the exact values for each angle and another angle that has the same trig ratio. So the first one says cosine of 225. So I think this is easiest if you sketch it. So remember, if I start at 0 degrees, up here is 90, 180, 270, and all the way back to 360. I won't draw this in each time, but if it's a positive angle, it loops around from the x-axis and comes to the terminal arm here. And you create your little triangle. So this is 225. And we want to find alpha, the related acute angle or reference angle. So in this case, remember, we figured out by taking the angle minus 180. So I got 225 minus 180, which gives me 45. So I automatically know my reference angle is 45, so I'm going to reference to the exact values in that triangle. And so if you remember, that means cos 225 is the same as 45. 45 is root 2 over 2, or 1 over root 2, whichever you prefer. The only other thing we need to think about here is that because of the cast rule in this quadrant, we have to decide if cosine is positive or negative. So because we see a t here, that means, remember, only tangent is positive, and that means cosine and sine are negative. So I have to put a negative value there. So that's where it's going to be. So that's the first part of this question. So that gives us an exact value for that angle cosine 225. The other part of the question says find another angle that has the same trig ratio. So if I do that, I have to think, okay, because this is a negative value for cos, where else is cosine negative? And this is where I would say, okay, I'm going to put in where it's negative, which is also in this quadrant, the S, where only sine is positive. So I draw my little triangle again, quarter of the bow tie, and I know that this is 45. So my second angle, if I draw it like this, let's call it theta 2. Theta 2 is going to be 180 minus 45. So I get 135. So I know that 135 is also an angle that would get the exact same trig ratio. So again, hopefully that's just review. The next one, let's try it. So we've got sine 210. So if we first draw it, so let's sketch it, and you can try this on your own. So 210 should go down here again in this quadrant. Oops. Do a little quarter of the bow tie. So that's 210. I can find alpha. Alpha is going to be 210 minus 180, which is 30. So now I've got sine of 30. So if you want, you can always go back up here and look at your little table. Sine of 30 is 1/2, or you can do whatever method you prefer. So that means sine of 210 equals 1/2. But I have to think of the cast rule to finish this off. The cast rule says in this quadrant again, sine is going to be negative. So I've got, that's my first answer. So that gives me the value where it's negative. So if I wanted to create another angle that has the same, where else is sine going to be negative? And the answer here is in this quadrant. So sine is positive up here and here, but it's going to be negative down here. Oops. So we do our bow tie. I know this is now 45 degrees in here, but what I want is all the way to there. So theta is going to be this time 360 minus the 45. So in this case, I get 360 minus 45 is 315, like that. So why don't you go ahead and try the next one? So again, I would pause this, and if you want, you can even try the other ones going on, but I will go through it. But I would pause it and try it yourself. So I'm going to quickly go through this. So I got 300 gives me that quadrant. That leaves, if I do quick math, that's going to be alpha equals 360 minus 300, which is 60. So it's tangent. So tan of 300 is the same as tan of 60. So again, if you need to, you can go back up, but opposite of 60 is going to be, let's see here. Here's my 60, so tan is opposite over adjacent, so I get root 3 over 1. So it's just root 3. And then I decide, is it positive or negative? And in this case, again, it's going to be negative because tan's negative in that quadrant. So where else would tan be negative? Well, it's going to be up here. So now I know my alpha, my related acute angle, is 60. So what I want is from here to here. Call that theta 2. So theta 2 is going to be 180 minus 60, which is 120. Okay. So I'm going to fill in the rest, but I think you've probably got enough. I might just skip down to the sine theta being 0, because I think that one's a bit different. But the other ones I think you can try yourself, but I will fill them in for you. But if you wanted to see this one, so sine of theta being 0, and so in this case, remember sine theta equals y. We have to think, when is y equal to 0 from 0 to 360 degrees? So that means I have a height of 0. So in this 4 options, really, oops, 270, actually it could be 360 as well. So when is it going to be 0? Well, I know that y is 0 here, and I know that y is going to be 0 here. So we've got theta is equal to 0 degrees, or theta could be also 180. So that means sine of those numbers, sine of 0 degrees equals 0. Sine of 180 is also equal to 0. Because the question asked between, if you go back up here, it says where theta is between 0 and 360, there's technically a third answer, and this is the only time you'll get 3 when it's between 0 and 360. You've also got this option where you could have wrapped all the way around where you have 360 degrees. So you have a third possibility where sine of 360 is also 0. So theta 3 equals 360. So a bit tricky to do those ones. Remember, you have to remember sine is y, cos is x, and tan is going to be y over x. Again, I will fill in the rest of this, but I think you probably got enough to be able to do this on your own. But give it a try and let me know if you have any questions. And please do help each other out. You can meet up on Microsoft Teams or whatever way you want to discuss things. Hope everything is going well.